Hey, what's up, app Morpheus? Welcome back to the commute, and in this video we're going to be exploring some data classes. Now there are certain properties in data classes, for example .toString, .pulse2, and I think so, .copy. We'll be exploring those as well. If you're an Android developer, you might have come across data classes because they are actually used in our models when we are trying to actually get the JSON response from the API call, and everything is stored inside of the model. Data classes are used inside of the model. So that is what data classes are. So data classes play an important role in Android development journey. We will try to explore that, and let's get into it. So let me quickly write down data classes here, and we have data classes. Okay, let's make a simple data class. Right now, a data class called vehicle, data class vehicle, and let's add a name into it, and let's add maybe number of tires inside of the vehicle. Now this is a simple vehicle, right? The vehicle should start with a V because it's still a class. Class should always start with a capital letter. As you can see, this is a special character in front of it, a special string in front of this particular class that defines this is a data class. That's how we declare data class in Kotlin. So what we are doing here is basically creating a class of data, right? Name, vehicle, and then we have constructor, and these two variables are being passed into this data class, right? This particular class will act like a holder. What do you mean by holder? It will actually store the data which can be used somewhere else. And for example, when we do an API call and there's a model class, right? And the model class is made up of data classes. Data classes will actually hold the data that we get from the JSON response, and then we can query that model to get whatever we want and do some kind of modifications on it and present it on the UI. That's how the flow works, and that's how data classes are used in Android development. Now, one more important concept here is that data class cannot be open or can be abstracted or anything. It means that they cannot be used to inherit like normal classes. They're just data holders. Yeah, of course, you can make certain functions inside of it. For example, function engine on. This will be a function inside the vehicle. It can simply print engine on or whatever the name that you carry in this particular data class. Of course, you can make functions. It is still a class, but you cannot abstract it or inherit it like any other class. Okay, I hope this makes itself a little clearer. Now, data classes have many properties. I will introduce these properties to you line by line, okay, step by step. Now this is called dot equals to property, right? Equals to property. Then we got dot hash code. Come on, dot hash code, and then we got dot to string, right? And then we got dot copy with small, and that is the certain properties that we use when we are modifying or using data classes, and let's explore them. Let's first of all make our data class, right? Vehicle, and say name as Mustang, right? And then we have tires, right? 4, of course. Then make another vehicle, name Mustang, and tires equal to 4. Now, if you know about hash codes, hash code simply means that if it is a particular class, let's take an example, a particular class like Mustang and tires 4, right? Let's suppose this is a normal class, not a data class. If we say dot hash code into it, it would only have this one particular hash code, right? A certain hash code. And whenever we try to access this particular class, it will only print the one particular hash code again and again. It won't change. The hash code won't change for this one particular class. In this particular vehicle, we have two vehicles, and we have just made two classes with the same name, same tires. Nothing has changed. Okay, and if we say one is equal to vehicle, or v2 is equal to vehicle. One more thing I want to point out is that var and val, it's compulsory to actually declare what kind of variable it is. It's a var or a val inside of data class. Without that, it will just shout at you, please declare something. Now we have v1 dot hash code, right? And v2 dot hash code. Let's see what it prints out. It prints out the same thing. It means they are actually the same classes. They're equal. I hope you understand that, because of course the values are the same and they're equal. I hope you understand that. Let me change this thing and let's see what happens. Now the hash code has changed completely. As you can see, it's a new class. Let me make it again 4, and they are same again. when you're trying to actually make vehicle again and again, it's actually a same class. And then if you try to make a new class, it will goes to a new hash code. It's simple as that. Now let's try to actually compare it with like double equal to sign, right? Let's try to compare it. Let's say v1 equal to v2. What will happen here? Okay, it gives us true. It means these two, basically these two classes are the same. There's no difference between these two classes. What about triple equals to? So the triple equal to actually means that they are pointing to two different objects. It means the vehicle 1 and vehicle 2 are actually two different objects, but they have the same value. It means that double equal to, as you can see, was giving me true, which means these two have the same particular value, which is of course true. Mustang and tires 4, Mustang and tires 4. So these two have the same value. The equality is true. But when we do triple equals to, we are actually comparing the referential equality. It means that we are actually trying to access does these two particular objects lie in the same position in the memory, or these are just two different objects in the memory. The answer is false. It means that they are two different objects inside of the memory. They are not referencing the same object in the memory. I hope this makes it clear. Now there's a particular function in a property inside of data classes which is called dot equals to, which can be used to actually compare the equality of these two data classes. And the dot equals to actually does not compare the differential equality, it simply compares the values of the data classes. Let me quickly do that. Dot equals to v2. Let's see what it does. True. Of course, it gives this the same value. Mustang tires 4, Mustang tires 4. v1, v2 has the same values. That's why it gives us true. Now it is giving me something here. Replace with double equals to. I hope you can see that. It's basically telling me to replace it with double equals to. It's similar to dot equals to. There's nothing changed, but there's a difference between triple equals to. This will be false because it compares your referential equality. I hope you understand that. Now let's try to actually access variables inside of this particular vehicle class and then compare the values. Okay, let's just make it Swift and tires still remains 4. Okay, and we will say v1 dot equals to v2. What happens here is false. Of course the values are different. We'll say v1 dot tires dot equals to v2 dot tires. True. The tires are equal, so it is actually trying to point out the tires of these two particular data classes are equal or not. Right. Another thing that I want to point out is these particular functions are only available in the data class. They are already pre-made functions given by Kotlin. These particular functions are not available in normal classes. Let's try to make a normal class as well and then see if it compares with the data class. Okay, let's compare a normal class here. Class. Right, now this is a very simple class. We'll say var v3 is equal to vehicle. What is it referencing to? Let's try to see. It's referencing to this particular data class. It is not referencing here. Okay, let's try to say vehicle 2. Copy this, paste it here. Okay, now this is being used right here. This is a total different class, v3. Let's say v3 dot hash code. Let's see what does it give us. As you can see, it gives us the hash code, which is of course made from the ninja, the values, whatever the values that are given to this particular vehicle. And we say dot equals to v2 false. Okay, it gives us dot equals to, which will be false. Of course these two particular values are different and they do not point, they of course do not point to the same object as well. So triple equals to does not work here. What about copy? Okay, the v does not have the copy function. Why is that? Because it is specifically available for only data classes. We can do that for v2. As you can see, that a copy function is available, but for v3 copy function is not available because it's a pre-made function that is only available for data class. Hope you understand that. Okay, now let's see. Tree.name. Can we access that? We cannot. We have to make some kind of object to return it, or we cannot access it because it's not var name. Can we say var or yeah, can we say var3.name? Yeah, now we can access. Of course, as you can see, the var was not compulsory in classes, but it was a compulsory in data classes. If we try to remove var here, it will shout at us. As you can see, add val or var to the parameter name. Okay, we will do some control Z, and that's some of the differences between a normal class and a data class. Data class is basically a holder to hold your data. That's all there is, and there are particular functions that are very customized to data classes as compared to classes, and that's how it plays out. Try to actually use the dot copy function, which is only available in data classes. Say dot copy. And what does it do? It produces the same copy of v2, right? And you can say Porsche, yep, Porsche car with the tires for. Okay, now we have dot copy, and it is shouting at us something else. Add name to call arguments. Okay, it's already there. The call arguments have the name, so yeah, we have particularly produced the copy of v2. Okay, let's say our 4 here. 4 is equal to v2. Now what we'll do is a v4 dot name. Let's print that out. As you can see, Porsche, and it just prints that. Now what actually the dot copy function does is basically it copies an object, allowing you to alter the properties of it, and while keeping the rest of the things unchanged. For example, let's say that this particular vehicle class has some other functions inside of it, and there's certain properties of it. We just copied this particular function and changed only, let's say, the name of it. The tires remain the same. As you can see, it doesn't shout. You can still access the tires, but it will be the tires that was previously mentioned in maybe in Swift. You can see it points to v2. The v2.copy, we just copied this particular class and changed certain properties of it. That's how copy function is basically used, and we can use it, for example, if you want to modify a certain class before sending the data off somewhere, or maybe we want to actually show it on the UI, and we are getting the data and we want to basically copy that particular model and modify it somewhere down the line in the flows, maybe, or maybe filter it and present in the UI in Android. We can do that with the help of .copy function. Hopefully this makes sense. Now let me explore one more, which is .toString function. As you can see, it's only available in our data classes. Now what we can do is actually, you can see the toString function. You can also see the toString function in a normal class as well. But if we try to use it, let's see what happens. As you can see, it points to the some kind of idea, scratch file generated something. It gives me some kind of memory location. And here we have a whole vehicle represented beautifully right here. So toString is a pre-made function. It has been overridden inside of a data class, but in the case of normal classes, it just gives us toString format of the particular class that we're accessing. This is the difference between these two classes. toString actually plays a different role inside a data class, is customized inside a data class, and similarly goes for .copy function, which is only available in data class. I hope these functions are a little clearer, and if you have any doubt, let me know. The comments are open for you. For now, let's try to actually read the documentation and see what are we missing, and see if you're missing anything. So this is a particular documentation right here, and what we have here: data classes in Kotlin are primarily used to hold data. As you can see, for each data class, the compiler automatically generates additional member functions that allow you to print an instant readable output, which means this whole thing is called .toString. Compare instances, which is .copy, a dot equals to copy instances, which is .copy, and more. Of course, there's certain different functions that are available in data classes as well. Data classes are marked with data. As you can see, a data class of user is present here. Compiler automatically derives the following members from the properties declared in the primary constructor: equals to, hashcode, toString. There's a different function. I haven't come across this particular function as of yet, so I do not know the use of it, but of course .copy function is used. And are there any other things that we need to be aware about? The primary constructor must have at least one parameter. Data class cannot be like, okay, just we created a class with no parameter. It should have one parameter, because we're trying to hold that particular parameter. All primary constructor parameters must be marked as val and var. As I've already said, data class can't be abstract, open, sealed, or inner. It cannot have any other properties other than data class. Okay, and these are certain explicit functions that are defined inside of the data classes. Properties declared inside of the data's properties can also be declared inside of H right here. As you can see, we have a val person. The person data class is present here. Person person1 dot age dot is equal to 20. Now the interesting thing is what will happen if we say person1 dot equals to person2. What will happen here? Println person1 is equal to person2 if it is equal. Turns out it is true, but the ages are different. Why is that? Because the age is inside of the class. It is not the difference in the data that we are trying to hold. It's inside of this particular class. The variable inside of this class is, it does not matter. We are not comparing that. We're comparing the primary constructor. That's what dot equals to stood for, right? And as you can see, automatically derives the following properties declared in the primary constructor. It compares the primary constructor. It does not declare the values inside of this particular class. I hope this makes it clear. Now print ln person1 with age, person1 dot age, person2 dot age. As you can see, this is different. And use dot copy function to make a copy of an object, allowing you to alter some of its properties while keeping the rest unchanged. The implementation of this function for the user class above would be as follows. You have a function copy, and it's pretty similar. We can just say dot copy right here, and this is how we do it, right? Jack age, and we just changed the age of Jack dot copy, and we have the new age, right? So this was the documentation. You can go ahead and read it. I hope you guys really enjoyed this thing, and this is it for now. I'll take my leave. Bye bye.